Hello, students. Welcome to today's Explainer. I am so glad you're joining me today. Go ahead, take a deep breath, get comfortable, and maybe grab a notebook and pen. Today, we are going to explore Chapter 6 from your Grade 8 Mathematics textbook. It's called We Distribute, Yet Things Multiply. Now, we're going to take this nice and slow, okay? I want to make sure you understand every single step. Together, we are going to see how some very simple rules of multiplication can actually unlock beautiful, powerful patterns in algebra. All right, let's dive right in. Here is our path for today. First, we'll look at the magic of distributing. Second, multiplying two brackets together. Third, the square of sums. Fourth, the difference of squares. And finally, number 5, fast math with algebra. Let's start with Section 1, the magic of distributing, from simple numbers to big ideas. You know, we always begin algebra by looking at what normal numbers do, because believe it or not, letters in algebra simply follow the exact same rules as regular numbers. So think about this multiplication, 23 multiplied by 27. Now ask yourself, by how much does your final answer increase if that second number, 27, just goes up by 1, becoming 28? Take a quick moment. What is actually happening in the math here? Let's turn these numbers into a picture in your mind. Imagine, right in front of you on the floor, 27 physical cardboard boxes. And inside every single box, there are exactly 23 items. Say, 23 apples. That is exactly what 23 times 23 means. Now, what happens when we do 23 times 28? Well, we are simply bringing in one more box. And what's inside that brand new box? Another 23 apples. So the total number of apples increases by exactly 23. This, my friends, is the core idea of the distributive property of multiplication. We are distributing the 23 to the 27 and then to the 1.
And you know what? We are definitely not the first ones to discover this. Ancient Indian mathematicians were absolute masters of this property. Way back in the year 628 CE, the great mathematician Brahmagupta wrote a famous book called Brahmasphutta Siddhanta. He explicitly described this exact method. He called it Khanda Ganandram, which basically translates to multiplication by parts. He figured out that if a number is just too big to multiply easily, you can just break it into smaller parts, multiply each part separately, and then add them all together at the end. Simple, right?
Moving on to Section 2, multiplying two brackets together, using letters to show universal patterns. Now, don't worry about the letters. We are just taking that exact same rule Brahmagupta used for numbers, and we're applying it to letters. Think about the letter A right outside a bracket holding B plus C. Imagine the letter A is a person standing outside a door, ready to hand out gifts to the people inside. The letter A has to hand a gift to B, and then A must also hand a gift to C. So A times B gives us AB, and A times C gives us AC. The absolutely crucial point to remember here is that whatever is outside the bracket must be distributed to every single thing inside the bracket. So let's see how this builds when we have two brackets next to each other, like bracket A plus B multiplied by bracket C plus D. We are going to do this step by step, very patiently. Step 1, we take the A from the first bracket and hand it out to both C and D in the second bracket. That gives us AC plus AD. Make sense? Okay, step 2, we take the B from the first bracket and hand it out to C and D. That gives us BC plus BD. Step 3, we just write all those pieces together. The final result is AC plus AD plus BC plus BD. Basically, every term in the first bracket goes and multiplies with every term in the second bracket.
Okay, Section 3, the square of sums, the first big identity.
We are now going to use that bracket multiplication we just learned to build our very first major algebraic identity. Students, please pick up your pens. I want you to write down this rule exactly as I say it. We call this identity 1A. Bracket open, A plus B, bracket close, squared, is equal to A squared plus 2AB plus B squared. Write that down nice and slow. This is a hugely important building block for your mathematics journey. It's a rule you will use for years and years to come. But look, as good math students, we never just memorize a rule without actually knowing why it works, right? So why does this work? Well, A plus B squared simply means taking the bracket A plus B and multiplying it by itself. So A plus B times A plus B. If we use our step-by-step distributing rule from before, we get A times A, which is A squared, then A times B, which is AB, then B times A, which is BA, and finally B times B, which is B squared. Now look closely at those middle terms, AB and BA. Because order doesn't matter when you multiply, BA is exactly the same thing as AB. If you have one AB and you add another AB, you get 2AB. And that brilliantly shows exactly where identity 1A comes from. Section 4. the difference of squares. Changing the signs.
So what happens when we change that addition sign to a subtraction sign? Let's find out. Please write this second rule in your notebook, right below the first one. Identity 1b, bracket open, a minus b, bracket close, squared, is equal to a squared minus 2ab plus b squared. Now compare this to the first rule. The only real difference is that the plus sign right before the 2ab has turned into a minus sign. Notice that the b squared at the very end stays positive. Why? Because a minus b multiplied by another minus b turns into a positive.
Now, let's try something really special. Let's multiply a bracket that has a plus sign by a bracket that has a minus sign. So a plus b multiplied by a minus b. If you distribute this out slowly, you get a squared minus ab plus ab minus b squared. Look at those middle terms again, a minus ab and a positive ab. They completely cancel each other out. They just vanish, leaving 0 in the middle. So we are left with just a squared minus b squared. This is often called identity 1c, and it is incredibly useful because it takes a very long problem and makes it super short.
Which brings us to Section 5, Fast Math with Algebra. This is your secret superpower.
I promised I would teach you a secret superpower, didn't I? Well, here it is. Algebra isn't just a bunch of random letters on a page. It's actually a tool that lets you look at really difficult number problems and solve them instantly in your head. Imagine I asked you to multiply 397 by 403 on a piece of paper. That would take a long time, right? But think about how we can rewrite those numbers. 397 is really just 400 minus 3, and 403 is just 400 plus 3. Does that pattern look familiar to you? It's exactly the a minus b times the a plus b rule we just saw, and we know the answer to that is simply a squared minus b squared. So to solve this huge, scary calculation, you just square 400, which is 160,000, and you square 3, which is 9. Then 160,000 minus 9 is 159,991. Boom, you just did complex multiplication right in your head using algebra. Let's try another trick pulled straight from Brahmagupta's ancient texts: how to multiply literally any number by 101 instantly. Step 1, break the number 101 into two easy parts, 100 plus 1. Step 2, distribute your number to the 100 first. That's super easy, you just add 2 zeros to the end of your number. Step 3, distribute your number to the 1, which just gives you the number itself again. Finally, just add those two pieces together. Let's look at an example to make it clear. Let's say 3,874 multiplied by 101. Instead of doing a huge, long calculation, just think about it like this. 3,874 times 100 is 387,400. Then add 3,874 times 1, which is just 3,874. So 387,400 plus 3,874 equals 391,274. See what we did? You break that heavy multiplier into parts, you distribute, and you add. It makes a really big calculation completely effortless. Before we wrap up today, I want to leave you with a really cool puzzle straight from the end of your textbook chapter. Try this out. Pick any 3 consecutive numbers in the whole world, say 5, 6, and 7, or even 100, 101, and 102. Take the middle number and square it. Then take the first and third numbers, multiply them together, and subtract that answer from your square. Go ahead, try it on your paper right now. If we use algebra to explain this, let's call the middle number n. So we have n squared minus the product of the numbers on either side, which are n minus 1 and n plus 1. Well, using our difference of squares rule we learned today, that becomes n squared minus, in brackets, n squared minus 1. The n squares just cancel each other out, and you are always left with the number 1. The final answer is always 1, no matter how huge the numbers you picked are. Isn't that amazing? Try it yourself with massive numbers and watch the magic of algebra at work. Thank you so much for studying with me today. Students, keep practicing and keep exploring these wonderful patterns.